Okay, today is basically going to be a review of law of sines, law of cosine, SOHCAHTOA, and Pythagorean theorem. And we're doing that in the form of word problems. Now, today, we'll have two types of triangles. If you look at example number 1, we have a right triangle. So if you have a right triangle, these are the only two routes you can go to solve your word problem. One thing you could do if you have a right triangle would be SOHCAHTOA. So you could find the sine using opposite over hypotenuse. You could find cosine using adjacent over hypotenuse. Or you could find the tangent, which would be opposite over adjacent. And you would use those mainly if you're looking for a missing side, or if you're missing, or looking for a missing angle. Or, one other thing you could do for right triangles would be Pythagorean theorem. So those are the only two things you can use if you have a right triangle. So if you're trying to solve problem number 1, and you're trying to do law of cosine, that would not be appropriate. You need to use one of those two, SOHCAHTOA or Pythagorean theorem. Now the second type of triangle would be an oblique triangle. An oblique triangle does not have a 90-degree angle in it. So if it's not a right triangle, the only two things you could do to solve your word problem would be the law of sine or law of cosine. So the first thing you'll have to decide is what type of triangle do I have, label everything, and then you'll be able to tell where's your next step. So looking at problem number 1, it says Jerry is snowboarding down a mountain from a diagonal distance of 10,000 feet. So the diagonal distance is going to be that hypotenuse. They said that diagonal distance is 1,000 feet. So I'm going to label that hypotenuse 1,000. Then it says his gauge speed is dangerously close to spinning out of control. The vertical drop. Which direction is vertical? Up and down. So the vertical drop would be talking about the height of that right triangle. And that vertical drop covers 174 feet. And as he slides faster and faster down the slope, what will be the angle of his run before he smashes into the diner at the foot of Mount Olive? Now, the angle of his run needs to be measured from a horizontal. Technically, the angle of his run would be that angle of depression right here. If I call that angle theta, that's an exterior angle to our triangle. So theta would also be located where in that triangle? The top angle or the bottom angle? The bottom angle, and that's because the bottom of the triangle and my horizontal line, they are parallel. This is my transversal, so alternate interior angles would be congruent. Now, solving for angle theta. This is a right triangle, so the only thing I could do would be SOHCAHTOA or Pythagorean theorem. But if you're looking for an angle, Pythagorean theorem is out of the question. So I have to do either sine, cosine, or tangent. So if I have the opposite side and the hypotenuse, which one of those three tricks would I have to do? Sine. So sine of theta is equal to opposite over hypotenuse. So 174 over 1,000. Now that's the arc sine value, so make sure you do second sign in the calculator. And for angles, we'll round to the nearest whole degree. And what would be the degree of that run? 10 degrees. So it's approximately 10 degrees. Next one, number 2. Number 2 says, because of prevailing wind, a tree grew so that it is leaning 4 degrees to the left from the vertical. At a point 35 meters from the right of the tree, the angle of elevation to the top of the tree is 23 degrees. Find the length h of the tree. First thing I'm going to do is draw a vertical line. So in the problem, they mentioned the tree is leaning from a vertical. So there's my vertical line. And they describe the tree as leaning 4 degrees to the left of this vertical. So I need to draw a tree leaning 4 degrees to the left of that vertical line. So that angle right there is 4 degrees. And then they say at a point 35 meters from the right of the tree. So from the tree, I need a point 35 meters away. And from that point, the angle of elevation to the top of the tree is 23 degrees. So now I need a line going from that point to the top of the tree, and that angle of elevation to the angle coming up is 23 degrees. And they ask us to find the height of the tree. Well, here's my tree. If they're looking for the height of it, they're just looking for the length of that tree. We're solving for side H. Now, looking at my diagram, I do know some other angles. What angles do I have right here between the vertical and horizontal? 90 degrees. So this is a 90-degree angle. What would this whole angle be? 94 degrees. 90 plus 4. Now, adding these two together, what's 94 degrees plus 23 degrees? 117. So what's 180 minus 117? 63 degrees. So this angle at the top is 63 degrees. So now I know all of the interior angles. Now we have to solve for side H. So looking at the big picture, so looking at the outermost triangle, what type of triangle is this? Right or oblique? Oblique. Oblique. So if it's oblique, I can only do law of sine or law of cosine. If you tried doing Pythagorean theorem on this, you're completely wrong. So only law of sine or law of cosine. Well, if you have an angle, actually this one, if you have an angle and a side pair, which one would be easiest to do, law of sine or law of cosine? Law of sine. We don't have to worry about law of cosine. Or actually, we don't have to worry about using law of sine because we know all the angles. So we don't have to worry about one being off 2. We already see that we have one that's off 2. Okay, so law of sine can be used. Now, if I'm using sine of 63 degrees, what side is paired with 63 degrees? 35. And we're solving for side H, and which angle is paired with side H? 23 degrees. So sine of 23 degrees. Solve that proportion by cross multiplying, so this would be H times the sine of 63 degrees equals 35 times the sine of 23 degrees. Divide both sides by sine of 63 degrees. And we'll round side length to the nearest tenth. And what would be the height of that tree to the nearest tenth? 15? 15.3? So 15.3 and the units are meters. So 15.3 meters. Don't forget the units. So 15.3. Next one, number 3. Air Force One has been hijacked. The president is hiding in the cargo bay. Out of a small window, he notices Munich, Germany, off to the right and at an angle of depression of 32 degrees. So the angle of depression would be the angle coming down. That angle is 32 degrees. So I know this angle of elevation is also 32 degrees. Alternate interior angles are congruent. Then it says that the plane is 10,000 feet from the ground. So this point right here would be the ground. And the distance from the plane to the ground would be 10,000 feet. And we want to know how far as the crow flies is the president from Munich. What does as the crow flies mean? How do crows fly?
In a straight line.
In a straight line. So we're looking for the straight line from the plane to Germany. So the straight line from the plane to Germany, they're actually asking us to solve for the hypotenuse. So as the crow flies means the fastest way. You need the straight line from point A to point B.
Wouldn't it be just a straight line from the bottom of the person? Or not the bottom of the person?
It's not asking us for the horizontal distance. They want to know what is the distance from the plane to Germany. Okay, so now what type of triangle is that? Is that a right triangle or oblique? Right triangle. So if it's a right triangle, you can use Pythagorean theorem or SOHCAHTOA. So here, looking at my 32 degree, we have the opposite side, we have the hypotenuse. So what we're going to have to use? Sine. So we need to do sine of 32 degrees is equal to the opposite side is 10,000. The hypotenuse is x. Multiply both sides by x. So it gives us x times the sine of 32 degrees is equal to 10,000. Divide both sides by the sine of 32 degrees. And what is x to the nearest 10? 18,870.8, and the unit would be feet. So don't forget to use 18,870.8. Now on the back, we have a nice picture for us. We have a picture of Mr. Joe Cool. And number 4 says that Joe Cool has a huge mole on the tip of his long nose. So here is the mole on the tip of his long nose. His nose is 2 inches vertically on his face. So vertical means up and down. And it says that from the mole to the bridge of his nose, so from the mole to the bridge of his nose would be this part. And what shape have I made? A right triangle. And we have a 50-degree elevation from the mole to the bridge of his nose. The question is, how far does Joe Cool's nose stick out from his face? Now, that triangle is a little bit small, so I'm going to make a larger picture down here. So here's his nose diagram. And they said that his nose is 2 inches vertically. So the up and down part for height of that triangle would be 2 inches. And from the mole, which was down here, to the bridge of his nose, which is up here, that angle of elevation, so that would be the angle coming up, is 15 degrees. And we want to know how far does Joe Cool's nose stick out from his face. So are they asking us to solve for the adjacent side or for the hypotenuse? The adjacent side. This bottom part down here would be how far his nose sticks out from his face. So we're solving for the adjacent side. So notice with the 15 degrees, we have the opposite side and the adjacent side. So what should we use to solve for x? Tangent. So tangent of 15 degrees is equal to 2 for the opposite side, x for the adjacent side. Multiply both sides by x. So that would be x times the tangent of 15 degrees is equal to 2. Divide both sides by the tangent of 15 degrees. And side length will round to the nearest 10. So how far does Joe Cool's nose stick out from his face? 7.5 inches. We have the honker there. Okay, last one. Moving on, number 5, it says that a ship sailed into harbor. The navigator sat the buoy at an angle of 15 degrees. What is a buoy? It's that little ball that floats in the water. So they see a ball floating off in the water. So they see a buoy at an angle of 15 degrees to the path of the ship. The ship sails 1,300 meters further and finds that the buoy now makes an angle of 29 degrees. Question A, we want to know how far is the ship from the buoy at the second siding. Now, what we need to do is make ourselves a diagram. Make ourselves a diagram. Okay, so this blue line represents the water. And we have a ship that's sailing. And then we have a buoy somewhere over here floating off in the water. So off in the distance, there's a buoy floating. And that ship spots that buoy, and they said that the angle from the ship to the buoy, they described it to be an angle of 15 degrees to the path of the ship. So this horizontal line is the path of the ship. So this angle of elevation is 15 degrees. So right here, this is siding number 1. But the ship is going to continue sailing, and it's going to stop somewhere, and it's going to spot that buoy a second time. And this point right here is going to be called the second siding. They said that at the second siding, it makes a 29-degree angle. Well, if this is a 29-degree angle, these two angles make a linear pair, and linear pairs add up to how many degrees? 180, so it's 180 minus 29. 151 degrees. And 151 plus 15 would be 166. So what would this top angle be? 14 degrees. So I have all 3 interior angles. And I need one more side. It says that the ship sails 1,300 meters further. So from the first siding to the second siding, they had sailed 1,300 meters. Now back to question A, we want to know how far is the ship from the buoy at the second siding. So here's the buoy, here's the second siding. So they're asking us to find that side that I labeled X1. So looking at that triangle, is that a right triangle or an oblique triangle? Oblique. So if it's oblique, I can use law of sine for law of cosine. Do you want to do law of cosine? No. So let's do law of sine. So for law of sine, if I use sine of 14 degrees, what side is opposite of a 14-degree angle? 1,300. And we're solving for x1. And what angle is opposite of x1? 15 degrees. So solve that proportion by cross multiplying. So this will be x1 times the sine of 14 degrees equals 1,300 times the sine of 15 degrees. Divide both sides by the sine of 14 degrees. And what is x to the nearest 10th, or what is x1 to the nearest 10th? 1,390.8, and the units were meters. Part B, what is the closest the ship will come to the buoy? Well, remember this bottom blue line represents the path of the ship. So the ship starts here, it sails to the second point, but after it reaches the second point, it's going to keep on sailing. So, at what point would this ship be closest to this buoy? When it's directly beside it, which would make a 90-degree angle. So the closest this ship will come to, I'm going to call that x2. So now I'm working with a right triangle. So looking at that right triangle, now I could do Pythagorean theorem, or I could do SOHCAHTOA. So looking at that 29-degree angle, we have the opposite side and the hypotenuse. So which trig function would we have to use? Sine. So this would be sine of 29 degrees is equal to the opposite side is x2. The hypotenuse is x1. And what do I need to put for x1? Yeah, the value we just solved for, 1,390.8. Now multiply both sides by 1,390.8. And we'll round to the nearest tenth. And what would that be to the nearest tenth? 674.3, and the units are meters. 674.3. Part C, last one. Part C asks us, how far must the ship go from the second sighting point to the closest point from the buoy? So here's our second sighting point. Here's the point closest to the buoy. So they're asking us for that base of that right triangle. So I'll call that x3. So if I'm solving for x3, it's still on a right triangle, so I have two options. I could use SOHCAHTOA or Pythagorean theorem. Now if I use Pythagorean theorem, I would have to use x1 and x2 to solve for x3, but both of these are rounded, right? So really, I don't want to do that. I don't want to use two rounded answers. So if I have the choice of using one rounded answer or two rounded answers, use the one with the least amount of rounding. So I really don't want to do Pythagorean theorem because that answer would be off slightly. So the other option would be a trig function. So looking at my 29-degree angle, if I'm solving for that adjacent side, what could I use? Well, we could use tangent, and we could also use cosine. Which one do you want to do? Tangent. Tangent? Okay. So this would be tangent of 29 degrees is equal to, the opposite side is x2, and what did we get for x2? 674.3. And the adjacent side is x3. Multiply both sides by x3. And last step would be divide both sides by the tangent of 29 degrees. And what is x3 to the nearest tenth?
1,216.5.
1,216.5 meters. 1,216.5. Okay, your assignment, you do not have to have notebook paper. You can do everything on the packet. So all work on the packet.